So what we're looking at is we've got a curve. Yeah. Don't disrupt. Okay, so we've got a curve. What we've done at this stage is be able to integrate the function. So if this is f of x, right, hopefully now you are able to find the integral of x cubed minus 4x with respect to x. Sit down please, Marco. I don't have time to plug in because you've turned up late. Okay, anyone want to talk me through that indefinite integral? All right, Judith, do you need to go?
No, I have like a problem with that. How do you think?
Okay, I'm just going to wash it out. Okay, who would like to talk me through the integral, the indefinite integral for that?
X to the power of 4 minus
So x to the power of 4 over 4 minus
4x squared over 2.
4x squared over 2, but obviously 4 over 2 becomes 2x squared. Okay, so this would be the integral. So that's kind of what we've been doing. We're okay with that. The next phase is to move into the definite integral, where we can use it to find the area under the curve. So x cubed minus 4x looks like this, right? And what we're doing is being able to work out areas. So, for instance, if I wanted to know the area under this part of the curve, right? So we've now got a definite integral, right? I'm looking for that area. And we have an upper and lower bound for that area. Right? So what we would be doing now is going back to my integration, right, notation. I would be having an extra to this notation, which would be what? Anyone who's read ahead?
We'll put the lower and upper down.
Lower and upper. Lower upper or up, lower upper?
Lower.
Lower upper. So this would be
Minus 2.
minus 2 there.
And then the other one will be 0.
So this is how we turn it into a definite integral. So we've got minus 2 and the upper bound is 0. Okay. So that's turned my indefinite integral into a definite integral. And what we will look at is, well, how we apply that. But to start with, what we'll do is, well, how do we find it using a calculator? So, upper limit 0, lower limit minus 2. Right. So, using your calculator then, to determine that area, right. Well, what I've done so far, I've changed it a little bit, but I've put the function in there. So x cubed minus 4x is already there. Right. So that's how you have to do it. You have to put the function into your graph first. If I just run through very quickly, it's very easy. You can do it afterwards. It's not, right? So I put the function in. Ignore that one. That's question 1. Not a problem. And then go to my calculate. So second and calculate, and down here number 7 is the integral of the function with respect to s. Press enter. Now there's a flashing cursor there. Lower limit. Ask for it. Now you just type it in. So I'm going to put negative 2 as my lower limit. Press enter. My upper limit is 0. Right. Press enter, and it will tell me that my answer is 4. Right? So the area is 4. Now what you'll find, because I've already done it once, is that my calculator is already shaded. That will come up on your calculator if you do that. So if you want to go through that yourself,
Did you plug in the integrate function or the...
I literally just put in the initial function, and then did integrate. Upper and lower limit, so -2, 0, and it tells me the answer is 4. Right. So I want you to have a go, exercise 9G. Do all the other ones if you haven't already. Right, okay, so there is another option, is basically what we're saying. The way I've just said to do it, which is you do your x to the power of 3 in your function minus 4x, and then you calculate, you do number 7. That's the graphing method, right? Just run through it again. I know we've done this over and over. 0. Right. Now there is another method which the reason why Avis has said she did it in a different way. The reason why I start with this method is because it's visual. You have the graph in front of you. What you should get used to, like with your normal distribution, you should try and visualize things. Draw the curve, put the picture, make sure it's very clear that you know what you're doing. Alright? But there is another way to do the same thing. So we know the answer is 4. So if we go through the other method, guys, maybe you'll consider it quicker or not, I don't know. In the math menu, so if you press the math button and then scroll down to number 9, function integration, right? If you press enter on that, you get spaces to put it in. Okay, so I need to put lower limit -2, upper limit of 0. I put my function in, so x to the power of 3 minus 4x. Differentiate with respect to x. Okay. Press enter, I get the same answer 4. So you've got 2 methods, should you wish to do either one.
I get -12.
So what happens if I go back to this and I want to know the area under this bit as well? So when we say the area under the curve, we actually mean the area between the curve and the x-axis. So we've got this area at the moment. The reason why it has to be like that is because if I go the other side of the line, the area is obviously infinite because it goes on forever. So you've got to have the area between the curve and the x-axis. So this graph is symmetrical, right? Therefore, you know this area is also 4, just common sense, right? But what about, so I think, well I know, if I did lower bound -2, upper bound 2, right, of x cubed minus 4x dx, I should get the answer 8. Now can you do it on your calculator for me? And tell me what you get. Okay, so your GDC's answer will give you 0. Any ideas why? Well, I'd tell you what to do. Do it in 2 parts and tell me what you find. So do -2 to 0, 0 to 2, what do you find out? So your calculator actually treats this as a negative value. Right. So we know the area is 4 and 4, but obviously for reasons of computing, your calculator will treat this as a -4. And obviously, if we do 2 to -2, your calculator will do, well, this area, add that area, and get the answer 0. Okay. Now that leads us into the next part, which is we have multiple areas, right? You're going to have to break them up. So over the page, right? you can see example 9. Well, above it in the pink box is just the notation for saying you need to add them together, you know. So from A to B, you've got to do A to C, C to B, okay, add them together. If you've got positives and negatives. And you can see that example 9 where you've got some above, some below, alright? And you have to do them all separately and then add them all up, right? You've got all those properties of definite integrals, but it's all basically just, well, you've got to add them all together and work them out so they're not negatives. There's a lot of fancy notation now, which is probably just to generalise things. You don't need to worry so much. Now, I'm going to get you to go through now then. So we're still on the phase of just using your calculator at the moment to find that area. So we're still practicing that way. So if you go through example 10 yourself, if you need me to go through it, we'll do it. Once you've gone through, get onto exercise 9H, have a practice. Then we'll talk next time about how we actually have to do it if we don't have a calculator. Well, not that we don't have a calculator, but how to do it properly.